Jim, where's my glucose? Hello everybody, and welcome to this week's episode of Dr. B. Now, today we're going to talk about my two favorite subjects, photosynthesis and cellular respiration. Take a look at this leaf. Doesn't look like much, huh? But what if I told you that it uses solar power, water, and carbon dioxide to make sugar and oxygen? Pretty crazy, huh? But I'm getting ahead of myself. Let's cut to Bill.
Look at this car. It runs on fossil fuels, or in this case, gas. When the combustion of fossil fuels occurs, or the burning of it, it releases carbon into the air and attaches itself onto plants. The plants uses it in photosynthesis to make oxygen for us to breathe and sugar for it to eat. Carbon dioxide is a greenhouse gas which affects the ozone layer and burns a hole through it so that it could harm the earth.
Thank you, Bill, for the interesting facts.
Wow.
Let's talk more about photosynthesis. The first part of this food-making process is the light-dependent reactions. Now, these start in the thylakoid, or grana for plural. The main purpose of this process is to make the materials for part 2.
What radical reactants are used in this process, Dr. B?
Well, sunlight and water, of course, Bill. As the electrons move through photosystems A and B, light strikes them to get electrons pumped up and water to replace the ones used. Now, through the energy of electrons and facilitated diffusion, it goes from high concentration to low concentration.
At the end of part 1, the electrons go through the and reduce NADPH. This produces O2, ATP, and NADPH.
Bill, I'm gonna fire you. You don't know your script. No, Bill, you don't know your script. Bill, just, why can't you be more enthusiastic? Bill, we're running a kids show. Come on. Bill, our pay is already almost... Bill, we have no funding. Bill, please.
Remember, kids, that's only part 1. We'll return with cellular respiration on Dr. B.
In a world where glucose is made one molecule at a time, witness the greatest film trilogy of all time on VHS, The Calvin Cycle. Watch the spectacular beginning, Carbon Fixation, where Carbon must keep the stroma cycle repeating while Rubisco tries to fix him up. Reduction introduces ATP and NADPH, which reduces the 3 carbon, sugar, to DHP. Finally, when G3P finally leaves, RUBP fixes itself to the other G3Ps to restart the process.
Coming soon to own on video and DVD.
Wow, what a great movie. Anyways, let's get back to our lesson.
Yay.
Cellular respiration is a totally righteous process. Remember those glucose molecules from before? Well, through the process of glycolysis, they split into pyruvates.
Fermentation creates ethanol for 21-year-olds and lactic acid along with CO2. However, this does not produce as much energy as the Krebs cycle.
That's our show for today. Thank you for...
Alright, I've got you now. You're under arrest for copyright infringement law from under Act 6285C. Mouse has got you now.
Three, two, one.
So radical.
That's right, Bill. They also split into the cytoplasm. Wait, what?